when we're given our equations in this factored form kind of style, we could go straight into like a positivity table situation. We know we can find what our roots are from here. Like if you want to find your degree, leading coefficient, and behavior first, totally valid. You don't have to. We can do this all with the positivity table to get to our image. All we need to know before I can do like a positivity table to figure out what this is going to look like is we need to know our roots. Where are we going to have roots on this one? That looks like it says rooks. 0, good. -2, +1, and 2. We've got a couple of double roots here. We know that there's going to be a bounce off a couple of these. That's actually still like already included in the positivity table. So if that's not something we're used to noticing or that we remember to look at, the positivity table covers your bases on that. Because when we set that up with our like number line for our roots and we put them in order, so I'm going to have my smallest one, that's my -2, and then 0. I'm going to need my line to be a little bit longer. Okay, we have our 1 and 2. 1's going to be a double root, and 0 is going to be a double root, but that's actually going to be covered in what we do in the positivity table. So we expect to see that happen, but like it's going to show us that. When we're filling in our factors off to the side, we're actually going to include those exponents on those factors. So I'm going to include this as an x squared. I'm going to put my factor of x plus 2 I'm going to have my x minus 1 squared and my x minus 2. And then the very bottom one's going to be our function when we multiply all our pieces together. So we know where our zeros are because it's already in that factored form. A couple of these are going to be really, really, really easy to fill in. Because x squared is going to have what sign? Positive. Every single time. No matter if my x's are smaller than -2, between -2 and 0, between 0 and 1, between 1 and 2, or between 2 and infinity, x squared is positive no matter what. And the factor x minus 1 squared, same deal. It's still being squared. Even if we wind up with a negative value inside this set of parentheses, we wind up with a square, so these are going to always have positive signs. So those two pieces are always positive. So when we have, including things like double roots, including those powers, when we set up a positivity table, anything squared is always going to be positive. So we really only need to fill in these two rows. So when we're looking at this row here, are we going to be positive or negative right here? Negative. Are we going to be positive or negative right here? Positive. And in fact, with these factors, these are linear factors, once it changes, it's not going to change back. Each of our rows should only ever have one change, really. We shouldn't go positive and then negative and positive in one row. Not until we get to our function. Because each of these factors are a linear factor, except for the ones we get squared. So on this one, bottom row, positive or negative? Negative. And then negative. And then negative. And then negative. And then positive. Oh, look, it changed. So then when we look at our function as a whole, now we're looking at our columns. Positive times a negative times a positive times a negative gives us positive. And then on the next column, negative, and then negative, and then negative, and then positive. Ooh, switch that to blue. So we are below the x-axis absolutely every time, from -2 all the way over to 2. We still have to come up and hit our 0 and hit our 1, but we stay below the x-axis. The only time we're above is when we're headed out towards infinity. So when we're looking at putting together a sketch here, we know our roots. We know our zeros. We're going to have one of them at -2. We're going to have to hit our 0, our 1, and our 2. Oop. And we know it's going to be above the x-axis to the left of -2. So over here, it's above, all the way out to forever. Everything between -2 and +2 is negative. So from here to here, I need to stay below my x-axis. So we're going to come down, down, down. They don't have to be the same height. They can be different sizes. Like you could go, little one. Whenever we have a negative sign for our function, that means it's below our x-axis. So everything from -2 to 2 is when we are less than or equal to 0. And then our last piece, from 2 on for forever, is going to go like that. So especially when it's in the factored form, just doing the positivity table gives you all the pieces we need. That's how we can prove and show for sure how these react and where these exist. Aside from just brute forcing logic. The problem with brute forcing logic is that's really hard to write on paper. It's really hard to show work with just the mental brain squeeze. I want us to do one more of these, at least to get it into factored form, because there's one on the homework that it's pulling up something from last chapter, but it's something we haven't talked about in a hot minute. But any questions on this one, 14? That one. So here we have x to the 4th minus x squared plus 8. And there's one in the homework kind of like this. 19 and 27 are both kind of like this. Because we want to try and factor this thing, because I can't do anything unless I know what my roots or my zeros are. But x to the 4th is not particularly pleasant to factor. What could we do?
Substitution.
This is a quadratic type equation. I have a trinomial, which should always kind of give us a red flag on that one. And this thing squared would be exactly that guy. So if I take this and set it as my u, my middle term here, when I square it, I should get my first term. So we're going to set u as our middle term. So u is going to be x squared. What that means is my u squared is going to be x to the 4th. So if I swap those out, if I do a u substitution here, our equation is really going to be u squared minus u plus 8. So we can go through this way. I was like, we're not going to do the whole sketch in the graph on this one because honestly, this one doesn't factor very nicely. And it's super gross and we'd have to do quadratic formula and I don't want to. The ones that have u substitution on the homework do factor nicely. We're not going to do full quadratic formula, but I wanted us to remind us of the u substitution. If I had that as a 2x squared, it would work nicely, but I don't. I think that's why it's not in my notes. I think I skipped that one last year. But I wanted us to remind us about the u substitution. That will come back. Like we need to be able to know how to get into a quadratic type so that we could factor it. So that is, it shows up on 27, and you can do it on 19 as well. You could also do 19 without it. But 27 will be very difficult if you don't have that. So check that. Be really careful with it. If this one doesn't factor, it's incredibly unpleasant. So we're going to look at the last kind of question. 37 has one like this. Or 37 is one like this. I just wanted to remind us about that u substitution thing. We're not going to finish right now because it was gross. Like it's genuinely terrible. In fact, I should delete that slide. It's awful. Or I should fix it. I'll do it another time because it's not up. So there's a question like 37 that looks like this. And we're asked to figure out a number k. So we're going to try and solve for k if we know that this graph contains the point -1, 4. And there's lots of different ways we can solve problems like this. There's one that's kind of intuitive, I feel like. If I know my equation and I know a point, what can I do with those pieces? Substitute them in. I know my x and I know my y. My x is going to be -1. My y is going to be that 4. I'm changing colors. So we can set up this equation as 4 equals, because that's my y value, 3 times our -1 cubed minus k times -1 squared plus our x again, there's that -1 minus 5 times our k, not x. So they have this most of an equation. Not all of it, most of it. Let's see if we can simplify this thing. What can we do that simplifies it? So we'll have our -3. Because -1 cubed is going to be -1. 3 times -1 gives us a -3. What do we have on this term? It's 1. So it's going to stay as a -k. Then we have our plus -1, so it's just a -1. And then we have our minus 5k, just kind of hanging out. Combine some of my terms. So we're going to have our 4 equals -4 minus 6k. What can we do from here? Add 4. So we have 8 equals negative 6k. Divide by negative 6. What will this k need to be in order to go through this point? Negative 8/6. Does it simplify? Negative 4/3. So if we had in this equation negative 4/3 here and negative 4/3 here, this would go through that point. Occasionally they will give us chaotic equations like that and say, find that letter. That'll happen in this section. It also happens in the next section where they'll do that. But those are all the pieces in 4.1. 37 has a question like this. 35 is really just kind of a logic thinking through situation, and everything else is a sketch or working with things that we've done before. So don't forget about how to deal quadratic type factoring, but we're going to work with other stuff for the rest of today. That's everything in 4.1. Okay. Questions on this one? I'm going to give us our start of 4.2. Starting a new section means we are going to have a new definition thingy. You don't have to write all the words. Just putting the formal definition up here. We are going to be dealing with division, with polynomials. You've done it before. This is just a really complicated way of writing it out on what we do. The thing we are going to wind up using most is this equation looking thing in the middle. Sorry, I'm just grabbing the highlighter real quick. This is the piece that we will wind up using the most. Because what we're doing is we're going to take our f of x and divide it by p of x. So we're usually dividing it by a factor or by like a linear statement. It might be a quadratic statement. We're going to have a polynomial and we're going to divide it by something. Dividing it by p is what we're calling that. And it's going to give us our quotient, which is the guy that's like on top if we do long division, and a remainder, anything left over that we couldn't divide out. And we're going to be finding q of x, which is our quotient, the thing our result of division, and r of x, which is our remainder. If we ever want to check our division, and there's going to be times when we write it in this way, what we divided by times what we have on the top plus any remainder would give us exactly what we started with. So if you think about, if I was to do like a long division, which I'm just pulling this out of my head right now. So if I divide 4 into 13, just thinking through, we know we have 3. We'd multiply this out to get 12, and we'd subtract to get our remainder of 1. The star? Yes. Sorry, I just wasn't in the math program, so I couldn't put the dot in the middle. So just with this kind of simple long division, 13 is our f of x, 4 is our p, that's what we're dividing by. 3 would be our q of x, and our remainder would be 1. R of x would be 1. I might throw those labels in here just so we see them. So this guy is our f of x, just so that we know what these pieces are we're looking at. I'm going to change the color on the 4 just so it's clear. So this one is our p. This one is our q of x. And this guy is our remainder, r of x. So if we do it as long division, that's where we can find all those pieces. Because if I wanted to multiply them back together, I could take my 4 times my 3 plus 1, and it would give me my 13. That's what this statement is saying. That 13 is made up of 4 times 3 plus 1. when we are done, and we'll know we're done dividing, our R of x, our remainder, needs to have a smaller degree or an equal degree to our P of x. Or no, R of x will have either will be 0 or the degree will be smaller. So if this still has the same as or larger degree than this, then we need to keep going and do another round. If this has a smaller degree than that, we cannot divide any further. We are going to practice this division. We've done division before. We had a couple of options in Algebra 2 when we were dividing. We've done long division, and we can do synthetic division. I'm going to start by having us remember our long division. I know, everyone's most favorite. Anybody need more time on this page? Okay, cool. Hanging out here for a minute. We're good? We're good on time. All good. I'm still hanging out here. I know it's not just one person. All right, you ready? Hang on a second. All right. So we are going to be given an f of x and given a p of x. So we're going to give something as our starting function, and we're going to be given something to divide by. So we are going to divide this. I'm going to set this up as long division. We're going to do that first. So we're going to do our old school long division house. F of x, our main function, that's what's going to go inside. 9x plus 4. Our p of x, what we're dividing by, goes outside. 2x minus 5. So when we're thinking about what's going to be on top, what we get as the result of our division, our quotient here, we think about our first two terms and what those two pieces would need to be in order to be divided. So if we think about them as like their own little mini division problem, if you remember this, if we take our 9x divided by that 2x, what happens when we have 9x divided by 2x? What do we get left over? 9 over 2. That's what we're actually going to put up here. 9 over 2. So look at our first terms, 9x divided by 2x. We're ignoring our constants for a second there. We just look at our first terms. Because we want this first term to cancel out entirely. I want to wind up with a smaller piece of information. So we're going to have our 9 halves now we need to multiply times this full piece over here. So we're going to get slightly more detailed than we did before when we did this in algebra 2. My stylus ran away.
Decimals, or should we stay with fractions?
You can do decimals for sure on this one. This is like, more often than not, it is going to be whole numbers. They just like to be mean and give us these hard ones first. My stylus ran away. I was about to just use my fingers. So what we're going to do is we're going to take this 9/2 times our whole factor and put it underneath under here. So 9/2 times 2x is going to give us a 9x. Because we're taking this times our whole factor over here and putting it underneath. Then I want to have my 9/2 times this minus 5. Which is going to give us a minus 9 times 5 gives me 45 halves. And I understand it is unpleasant. Because I heard someone whisper, where did we come up with the 9/2? Came from our first two terms being divided. Once we have that, what we're going to do is we are going to subtract these two rows. And we'll see why we have that fractiony grossness. Because now I have my 9x minus 9x, and my x's canceled out. I have 0 x's anymore. We just have constants. Whenever we're doing long division, that first term needs to cancel out. Should always cancel out. Otherwise, we're going to wind up with our remainder having that same degree, and we wanted it to have a smaller degree. So then we need to do our 4 minus negative 45 halves. So that one, yep, because we are subtracting this whole row. So it becomes the same thing as 4 plus negative, or 4 plus 45 halves. So what is 4 plus 45 halves? 53 halves. Because 4 is the same thing as 8 halves. 45 plus 8 gives us 53. So we're asked to figure out our quotient and our remainder. Our quotient, that q of x, which I've used this color too many times for too many different things. Fine, I'll do this. Our q of x, our quotient, is what's on the top. Q of x is 9/2. Our r of x, our remainder, is 53 halves. We need to make sure that our r of x has a smaller degree than our p of x, what we divided by. This has degree 1, this has degree 0, so it is definitely smaller. We can absolutely check that we did this correctly, because I know especially when it's worded this way and very weird, we are unconfident in ourselves. We could do this by checking to see if our f of x really does equal our quotient, that q of x, times the p of x plus the remainder. So you could absolutely substitute these pieces back in to check. I could take my 9/2 times 2x minus 5, and then add this, and I should get exactly 9x plus 4. So if we are feeling unconfident, or if it says specifically we need to check, this would be how you do it. We use that statement that was in the middle of our definition, and that's our check right there. 9/2 times my 2x minus 5, and then plus 53 halves. Will absolutely give us back what we started with. So that expression right there is the check. The answer we were looking for, our quotient and our remainder, were these two guys over here. Whoa, thick marker. Divide. We're going to practice this again. Where we're going to be given a function and given something to divide by. And we're going to find our quotient, like the result on top, and we're going to find our remainder. Questions on this first cycle of it? The next one's going to be a little bigger. This one will be our last one for today, for sure. We'll stop here. So we're going to set this one up. We're going to do this with long division. Our f of x is 2x to the fourth minus x cubed minus 3x squared plus 7x minus 12. And we're asked to divide that by x squared minus 3. So we're going to set this up. I'm going to have my 2x to the fourth minus x cubed minus 3x squared plus 7x minus 1, 12. I had it zoomed in too far. That's this guy. And we want to divide that by our x squared minus 3. Oop, that's not the eraser. I'm gonna make that slightly darker. That just felt really pale. Thank you. Cool, cool, cool. Oh, it is right now. So, look at our first term and our first term. First thing we need to do is figure out this divided by that. There, it's here. So we're going to check our first term divided by our first term. That's how we decide what goes up on top. So we're going to have our 2x to the fourth divided by x squared. What are we going to have when we simplify this? Looking at just our two first terms. 2x squared. It goes up on top. 2x squared. Now I'm going to take this times this whole thing and put it under. So my 2x squared times x squared, that's going to give us a 2x to the fourth. And my 2x squared times minus 3 is going to give us a minus 6x squared. I'm writing it underneath the x squareds, so when we're doing our subtraction, I can combine them together. You can just leave a little gap right here and line them up. You don't have to line them up, but it makes it a whole lot easier if you do. Because then we're going to subtract all of it. (2x to the fourth minus 2x to the fourth gives us 0x to the fourths. That's the whole point. This first term needs to cancel out. If it doesn't cancel out, something went wrong and you stop and check in. First term should always cancel out. These x cubes don't have anything being subtracted from them, so they're just going to drop down. Our minus x cubed. Then we're going to have our minus 3x squared minus negative 6x squared. I'm going to switch this to be a darker color so it doesn't blend in with that line right there. So we're going to get a positive 3x squared. Everything else just kind of falls into place. That whole first term cancels out. If that whole first term doesn't cancel out, something went wrong. The whole first term should go away. Then I know we're going to look at this and go, sweet, we can be done, right?
No.
If this has a smaller degree than that, we can stop. Is our degree smaller here?
No.
Do it again. Round 2. Good. Now we're going to look at this polynomial that we're going to divide by this guy. So we're going to do a whole different first term situation. So we're going to look at this first term and this first term. So our minus x cubed and our x squared. Yeah. That's just going to give us a minus x. Because 2 of my x's are going to cancel out. Then we do the same kind of deal. I'm going to take my minus x times the whole term over here and put it underneath. So when I have minus x times x squared, we're going to have minus x cubed, which is what we expected. And my minus x times my minus 3 is going to give us a plus 3x. Then we need to remember that we need to subtract this whole row. Subtract everything. So my x cubed minus negative x cubed. We get our 0x cubed. That first term cancels out as it should. Again, if the first term does not cancel out, something went wrong and we need to stop and figure out what happened. And then we're going to have our 3x squared minus nothing, which is just going to be our 3x squared. We have our 7x minus 3x plus 4x minus 12 minus nothing minus 12. Is our degree here smaller than that?
No.
One more time. This one takes 3 rounds. So we get to do that one more time. Got 3 minutes. Same vibe, same process. I take my first term, 3x squared, dividing it by our other first term, that x squared. We're going to end up with just our positive 3. When we multiply that times everything on the left-hand side, we're going to have our 3x squared minus 9 that we are subtracting from everybody. So our 3x squared minus 3x squared cancels out. That's the whole point. That guy should disappear. Our 4x, we have nothing to subtract from, so it's just going to drop down. Negative 12 minus negative 9. Negative 3. Does this have a smaller degree than that?
Yes.
Finally. We're done. Our Q of x, our quotient. Let's see, I don't have any colors I haven't used. I used them all. This guy is our Q of x, our quotient. This guy down here, our 4x minus 3, that's our R of x, our remainder. As long as R of x has a smaller degree than our P of x, we're done. Okay? So quotient, the result we get is what's on top. Remainder is the guy at the bottom. Next week we'll review our synthetic division, which is a lot of times faster, but that doesn't work when we have division by quadratic pieces. Synthetic division only works when we have linear factors. So we will need to be able to do both long division and synthetic division. So, just saying. I'm going to put up the homework numbers so we've got them. Here's everything. 4-1, 4-2. Reminder, the PSAT is next Thursday, and we're going to have our first quiz of this chapter next Friday.